Hello pre-calculus students. We continue our work with triangles by working on the law of cosines. And for this proof, and this is in fact a proof, I'm not going to start by giving it away. We're just going to kind of work through this triangle and see what comes out of here. And our goal here is to be able to solve this triangle using only the parts of the triangles that are the sides or the angles. So using only angle A, B, or C, or sides little a, little b, and little c. I've drawn in the altitude here to help us a little bit, but in the end the goal again is we should have everything defined in terms of A, B, and C. Okay? Because when it comes to triangles, that's usually what we're going to be given. We're going to be given sides or angles, and that's it. And one of the motivations for the law of sines is for the law of cosines is the limitations for the law of sines. If you work with the law of sines a little bit, you know that there are certain cases that can't be solved. If you're given three sides, the law of sines can't solve it. If you're given side, angle, side, the law of sines can't solve it. So let me give you these cases. If you're given side, angle, side, or side, 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 it is not possible to solve with the law of sines. So this requires law of cosine. So I'm going to do this proof here, and then we'll do some examples, and you can see why this is. Okay, so just to write this down, we'll keep a little bit of a note on this as we work through our proof. So to set up this proof, what I'm going to do is define some more variables. So I'm going to call this side x, and that's just between this where the altitude intersects the side of the triangle, and this side is going to be c minus x. Okay. So one of the things I'm going to use here is the Pythagorean Theorem. So I know that looking at the triangle on the right here, x squared plus k squared equals a squared. So I'm going to say x squared plus k squared equals a squared. And my reason here, I don't have enough room to write all my reasons, but I want you to note that this is the Pythagorean Theorem. On the left triangle, c minus x squared plus k squared equals b squared. And you just got to be careful that c minus x is a quantity. You can't separate it. Plus k squared equals b squared. Okay. So I have sort of two equations here. That's just basically using the Pythagorean Theorem, and there's a lot of common variables. And so what I'm going to do next here is, we'll call that step 1. In step 2, I'm going to solve for k squared for both of these. And my motivation for solving for k squared is so that I can eliminate it and define things in terms of a, b, and c. Keep that goal in mind. We want to define everything in terms of a, b, and c. So this becomes b squared minus quantity c minus x squared. On this side, it's going to be k squared is equal to a squared minus x squared. Okay, and so that's step 2. Now, since these expressions are both equal to k squared, they must be equal to each other, and that's called the transitive property. So now I can say that b squared minus quantity c minus x squared is equal to a squared minus x squared. And I'll actually write the reason here because this is an important one. This is the transitive property. Okay. I'm going to continue my work down here. Now, again, I'm going to try to get all the x's on one side so I can eliminate the x's. And my goal here is, once again, define everything in terms of a, b, and c. So, and it doesn't matter whether you solve for a squared or for b squared. I'm just going to go with b squared, and this is completely arbitrary, is equal to a squared minus x squared plus, since we're adding to both sides, quantity c minus x squared. We're going to continue with the algebra and just work on the right side a little bit. And we have to be very careful This is so tempting for students just to say that c minus x squared is really c squared minus x squared, but we all know better, and this is really c minus x times c minus x. Okay. So to expand on that, we're going to get b squared equals a squared minus x squared, and we can distribute this or FOIL it or however you want to call it, but we're going to get plus c squared minus 2cx plus x squared. And at this point, our expression gets a little bit simpler, because you can see here that I have a negative x squared and a positive x squared, and so those two are going to effectively cancel each other. So I have b squared equals a squared plus c squared minus 2cx. And I'm getting pretty close to my goal, and my goal again is to define everything in terms of a, b, and c. I'm getting pretty close. I still have this x in here, and I want to find a way to get rid of it. And in order to really fully remove it, I have to use a trig ratio, in this case the cosine ratio. So if I just cover up the left side of this picture here, you can see that cosine of angle B is equal to x over a, adjacent over hypotenuse. So in step 8, I can say cosine of B is equal to x over a. Now you might ask, why would I use cosine, why not sine? Well, if I use sine, I bring k back into the picture. And if I use cosine, that will allow me to solve for x and eliminate it. And so let me write the reason here, and this is the definition of cosine. And we're going to multiply both sides by a, so a times cosine b is equal to x. So lastly, I can take this picture, this out of the way now. In step 9, I've solved for x, so I can take this expression and substitute it in here. Okay. So really my last step here is b squared equals a squared plus c squared minus 2c times a cosine b. So I'm gonna rewrite it just so that it looks a little bit nicer. This really isn't anything special, but I'm gonna rewrite it as a squared plus c squared minus 2ac times cosine b. Okay, and there it is. Our proof is complete. So we're able to solve this triangle using 3 sides and 1 angle, okay? And that's significant. So if you know 2 sides, if you know a and c and 1 angle, you're able to solve for the 3rd side. Or if you know 3 sides, you notice here the special thing about this is if you have a case of side, 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 if you know a, b, and c, then you can use it to figure out one of the other angles, one of the angles in the triangle. Okay. Now this is a kind of a bit of my challenge to all of you, is that there's actually 3 parts to this law, to the law of cosine. So what we've done here is just one part. There's actually 2 other ways that we can express this, and I'm going to leave this to you to prove, and you should practice doing this. So we can also, try to prove, and we'll call this your homework, prove that a squared is equal to b squared plus c squared minus 2bc times the cosine of a, and also to prove that c squared is equal to a squared plus b squared minus 2ab times the cosine of big C. Okay, so this part here, if you're watching this, and whether you're one of my students or not, it's a wonderful way to try to understand this theorem. This is a very powerful and useful theorem, the law of cosines. So, boxes, and this is what we proved so far. Okay. So this is proved. And this here in green, I'll leave it to you to do.